بسم الله والصلاة والسلام على رسول الله. I am Dr. Abdulaziz ibn Hussein Al-Anazi, an assistant professor in the Department of Chemical Engineering in King Saud University. It is my absolute pleasure to be here with you today for the 10th International Conference on Water Resources and Arid Environment. For my presentation today, I will be talking about promoting nanotechnology innovation for clean and safe water. So we will have an introduction, then we'll talk about water conservation and reuse. We will also talk about emerging technologies for water treatment and nanotechnology. We'll also talk about and focus on advanced oxidation and advanced reduction. Then we'll have a conclusion. So there is a lot of water on Earth, but only a small amount of it is fresh water. And even a smaller amount is readily available fresh water. Most of the fresh water on Earth is contained in ice or deep underground that we do not have an access to. Out of the 2.5% fresh water on Earth, only 1% is readily available surface water in lakes, rivers, and reservoirs. Water is linked to the development of all nations. It covers about 71% of our planet, but again, the fresh water can be used to drink or to use it for agriculture is very limited. Unsustainable development is placing a pressure on water resources. It's reported by 2030, the global demand on water is expected to increase by 50%. So there are many factors that contribute to our water challenge. Water availability is heterogeneous across the world, so any proposed solution must be taken into account. Agriculture, again, is the largest freshwater user in the world. So this sector has a huge impact on water availability and leading to water scarcity. Water pollution and lack of sanitation systems result in many people drinking unsafe water and even drinking untreated water, even in areas where drinking water is treated. Now we have emerging contaminants that pose short-term and long-term health effects. Climate change affects many regions across the world in many different ways. It's projected that while some areas will face heat, water stress, or lack of water, other places will face flooding due to increased frequency of extreme storms and environmental events, also including sea level rise. The water issue will go face and hand to hand with the climate change. It's been reported that 1 degree Celsius is increasing global average since the pre-industrial age, where we're trying to make more cars, more factories, more and more without focusing on our environment. Climate change is disrupting weather pattern, weather scarcity and water scarcity caused by climate change can cost some regions up to 6% of their total GDP. Reducing water resource can be a major challenge, even for water modern countries, like I mentioned in the previous slides, because of the risks the emerging contaminants pose. Insufficient water use and high water consumption rate, especially in agriculture. Saudi Arabia has the third highest per capita freshwater consumption in the world. The daily per capita water consumption increased from 227, I think, in 2009 to 278 liter in 2018. it has costs associated with it. The cost associated with the reliance on desalination is very high. We relied on, in Saudi Arabia, in this area of the world, we relied on desalination since the 1950s, and we became, as a result, is one of the leading desalinated water in the world. Very advanced desalination techniques have been used in Saudi Arabia. I think it's about 7.6 million cubic meter is produced daily, which is accounting to 22% of the global production of desalinated water. Water loss is another issue and challenge. Water loss in the network is one of the like the water networks is one of the main challenges. It's estimated that 25 to 40% of water loss in the globally in the water systems, which is it has to be accounted for, and we have to find many ways for detection. In this area, again, in Saudi Arabia, we developed new techniques to control water loss. So solving the water losses issue and the water challenges in Saudi Arabia, Saudi Arabia, many initiatives came in, like Qatra, which aims to cut water consumption by 43% to 150%, 150 liter per capita per day by 2030. We are honored and pleased in Saudi Arabia to have His Royal Highness King Crown Prince Mohammed bin Salman and the vision of 2030, which lays and puts the goals and targets for us to a better future. So when we talk about water pollution comes from many sources: agriculture, municipal, industrial, and being some of the biggest contributors for water pollution. Due to water pollution, unsafe drinking water is a huge issue because more than 3.4 million people die a year from water-related diseases. Even in area with access to treated drinking water are facing some challenges with treated water, such as PFAS, microplastics, and some antibiotics that are resistant to water treatment systems. Research shows that these contaminants are available in the effluent and the effluent of water treatment plants. More than 3.4 million people a year, as I mentioned earlier, suffer from diseases related to water contamination. Now, globally and in the US, emerging contaminants are generated by human use, like sunscreens, wasted pharmaceuticals. They find their way to water. Are public concern. Drinking water sources are affected by agriculture's runoff and industrial and municipal wastewater discharges. The designs of conventional water treatment, they don't necessarily remove. They're all designed for COD, ammonia, TDS, chloroforms. However, the pharmaceuticals and personal care products have found their way to be resistant to these two conventional water treatment plants. So contaminants of emerging concern are chemicals and other substances that have no regularity standards. They are emerging and new, have been recently discovered in natural streams. There are many pollutants not currently included in routine monitoring program and may be candidates for future regulation depending on their ecotoxicity and potential health risks and environmentally relevant toxic level. These contaminants are even a concern of people who have access to treated water, like I mentioned earlier, because it's proven that they're found in treated water. Sustainable development goals for water sustainable future. Water conservation and reuse to enhance water supply, water reuse, water reuse again. I always focus on water reuse. To be environmentally conscious and for treatment of emerging contaminants and pollution, creativity, innovation. It's very, very important in any approach in our life, I believe. So creativity treatment technology for water reuse and circular water economy. We talk about carbon, circular economy, carbon footprint. It's time to talk about circular water economy and focus more on innovation on circular water economy. Any beneficial, when we talk about water conservation, it's a tool that we can use, very effective tool. So water efficiency is a tool of water conservation that result in more efficient water use and thus reduce the water demand. The value and cost effective of water efficiency measures must be evaluated in relation to its effect on use and cost on other natural resources. So sustainability to ensure the availability for future generation. The withdrawal of fresh water from ecosystem should not exceed its natural replacement rate. Energy conservation, water pumping, delivery, and wastewater treatment facilities consume significant amount of energy. In some regions, like the US and California, one of the largest, 15% of total electricity consumption is devoted to water management system. Habitat conservation. Minimizing human water use helps to preserve freshwater habitats or local wildlife. So on water conservation technology, the process of conservation may be synonyms of preservation against loss or waste. It means putting the water resources of the country to the best beneficial use with all the technology at our command. Water conservation basically aims to matching demand and supply. The strategies of water conservation may be demand-oriented or supply-oriented or management or management-oriented. The strategies may vary depending upon the field of water use. It's either domestic, irrigation, or industrial use. For example, rainwater harvesting, where it's you can control the runoff of buildings and storing the rainwater underground for later use. Rainwater harvesting is an artificial recharging are becoming very important issue, and it is essential to stop the decline of groundwater levels. It has many advantages. It is sufficiency to water supply. It reduces the cost for pumping underground water, for example. Provides very high water and soft like water quality. It's easier to treat, improves the quality of groundwater through the dilution when it's recharged, and many other advantages. We have to use better irrigation practices. Conservation of water and the agriculture sector is essential since water is necessary for growth for our plants. The use of saline water, some crops and some plants, they can be fed with saline water, and it's widely available, but it's rarely used. Mulching also. It's the application of organic and inorganic materials such as plants, old plants, waste, composites, new composites, improve soil moisture. It reduces evaporation and loss of moisture from the ground and improves the soil fertility. Also, tippy tap for water conservation. The tippy tap is a simple device which can be found and placed on the water tap that dispenses a limited amount of water and facilitates through when you use it for wash, for wudu. In case of piped water supply, every time a tap is opened for hand wash, an average 300 to 500 milliliter of water is utilized. Using a tippy tap, it is possible to reduce it to 60 to 80 milli, from 300 to 60. That's a lot of water being saved. Tree plantation, and of course, desalination. Desalination is advanced and depends on the techniques. We have many different techniques for desalination. More on water reuse. Water reuse, also commonly known as water recycling and water reclamation. It's very beneficial. Water reuse provides alternative to existing water supplies. Many areas in Singapore, global, in California, they started relying on water reuse. There are many approaches for water reuse. You can use it after completely treat your water. You can use it for underground recharge fires. You can use it for as a feed. Many studies now they show the possibility to use this water for the feed of desalination plants. Managing water is a global challenge that impacts the environment, social, economic, and political constraints in this earth. Effluent reclamation and reuse provide opportunities to conserve water and maintain the quality of the existing freshwater supplies. So we have to maintain what we have, and water reuse for various purposes is increasingly practiced throughout the world, as I mentioned earlier. When integrated to our water resource management, the water reuse, it can be considered as an integral part of pollution control. This is very important. And water management strategies. It may also result in benefits for the public health, applied water reuse. The water cycle ensures that used water will eventually work its way back into the nature, but it does not always end up in reservoirs that we can have an access. Most humans get their water via rivers, lakes, and groundwater, but we have to make sure and develop a special good enough technology that reused water can be used for everything. Water is the most valuable thing we have on earth. Allah subhanahu wa ta'ala وجعلنا من الماء كل شيء حي. When we take water from any natural source, we have to always be environmentally conscious. Wastewater treatment is a process, we talked about that, of converting wastewater to water that can be discharged back to the environment and futurely to the water that we can use. According to the US EPA, one of the most common forms of pollution control is wastewater treatment. It is the process where we speed up our natural process of water treatment. Water is naturally treated through the earth, but wastewater treatment plants will speed up this process. Wastewater is formed by a number of activities like human use, And the more challenging is industrial wastewater because of the type of waste in it. So more on emerging technologies for water treatment. We have membrane technology is well-developed technology, and it's advancing more and more. So membranes are classified as a thin layer barrier for size differential separation, which are usually integrated with chemical and biological treatment processes or as standalone technology. For a typical membrane mechanism, there is usually a driving force, such as a semi-permeable barrier, which controls the rate of movement of component by fractional permeation and rejection through the pore size of the membrane. There are many types of membranes. We have microfiltration, they apply microfiltration, ultrafiltration, ion exchange, reverse and forward membrane, electrodialysis and electrodialysis reverses membrane. Also, we have for treatment, we have microalgae. The use of microalgae based wastewater treatment depends on the type of algae, and there's a lot of science in microalgae. The size, the type, the species. They are common open pond and closed bacterial reactor. Also, we have the microbial fuel cell. Microbial fuel cell are chemical reactor system that generates electricity from biodegradation of organic material with the help of suitable microbial substrate. Typical type of microbial fuel cells have three major components, which is the electrodes, separators, and electrons. The impact of nanotechnology and nanotechnology trend in the advancement of methods and techniques for water treatment would be more promising in the years to come. Scientists are working so hard to develop the nanotechnology, and nanotechnology has been recognized as a technology that could play a significant role in many environmental approaches in addressing many problems associated with water purification. Recently, many development in nanotechnologies and wastewater treatment based on nanofiltration for biologically treated sewage. I think this study talks about sewage treated from deprivation of organic chlorines tissues and paper industry by manganese doped zinc oxide nanoparticle have been creating promising results. Different metal kettles has been synthesized in nano size, and their application for water treatment has been in studies. Us, with the research group I work with, we developed a new eco-friendly nano catalyst for oxidation technologies, and also to monitor these new emerging contaminants. The nano catalyst we developed works very environmentally friendly. It works with catalyst, works under, you don't need a source of light like many photo catalysts. We focus on catalysts that work in dark, and it works through the advanced oxidation mechanism. So we developed a new eco-friendly oxidation technologies for with nanomaterial to treat these contaminants. We treated, as I will show on the coming up slides, we treated sunscreens. In one case, we treated PBSA, sulfonic acid, as a sunscreen, and in another case, we treated pharmaceuticals, diclofenac, as they're both been proven to find on the effluent of water treatment plants, and they were very hard to treat. So we use transition metal-based catalyst, which we have various, it has physical and chemical and magnetic properties. So the catalyst we develop, it has the magnetic properties that after we degrade our emerging contaminants, we will be able to collect it back and reuse it again. So mechanically or mechanistically speaking, on the mechanism, zinc ferrite combination will release electrons upon the contact with aqueous solution via oxidations of Fe2 plus to Fe3 plus, which you will see in the XPS. As we put that in the XPS, what we did actually, we tested the catalyst after removing and after degradation of the emerging contaminants. We tested it before use and after use. Then we focused on the XPS. And the XPS, we were able to explain the results and extract new results that explain what was done. So the generated electron from the zinc ferrite nanomaterial on the surface interact with oxygen, molecular oxygen and water to generate superoxide anion that further lead to the formation of hydrogen peroxide, which will also take a second pathway of oxidation. So we have an oxidation pathway as presented here, and reduction pathway to degrade diclofenac. All aims to improve the quality of degrading these contaminants and have multi-disciplinary approach. So our catalyst we developed for reduction and oxidation. We showed that it's actually we're able to reduce the non-oxidizing agent potassium permanganate, and we were able to show per naked eye the color change with the catalyst. Here we have no catalyst added, and here once we add the catalyst from A going to B, C, D, how the color changed. Also for the oxidation, we use the quenching agents, and for example here we use no quenching agents for the hydroxyl radicals, and once we have less quenching agents, tetrahydrobutanol, we had more less quenching agents, we had more degradation. Once we added more quenching agents, we had no degradation, target contaminants. We also, as I mentioned in the previous slides, in here we see the before use. So before using the catalyst, we did an XPS analysis, we did the envelope peak, and we also focused, we quantified, we modeled the peaks via software called CASA XPS. We modeled the peaks, and then we saw Fe2 plus and Fe3 plus peaks. However, after using the catalyst, percentage of A2 plus to Fe3 plus were changed to be 50-50% compared to 63.49 to 36. So we see the difference between before and after, confirming our suggested mechanism for the degradation. We also, in a previous paper, we developed similar catalyst, but on the form, instead of zinc ferrite, we used cobalt ferrite in addition of proxy monosulfate to generate sulfate radicals for the degradation of sunscreen PPSA. These catalysts are environmentally friendly. We studied the byproducts generated. We have no harmful byproduct. We also don't need to add any sanitation, electricity, UV, so they are energy efficient and they're very effective. And more importantly, they're usable. Because of their magnetic properties, we can collect them back. Move this here a little bit. So the magnet, you can collect them back and then reuse them back again after regeneration, which is very affordable. So will nanotechnology solve an arid environment? Nanotechnology has very promising results. The ease of, after creating them, we can scale up. Uh, they are very environmentally friendly and they require not a lot of maintenance. So I hope in the future we'll develop our technologies with collaboration with many scientists, and especially after we receive the recognition from the world's best prize on water, Prince Sultan International Prize of Water of Creativity. With Dr. Dion, I had the honor of receiving the Prince Sultan International Awards on this nanomaterial, along with some other mechanisms that he will present to you. Thank you so much for allowing me to present to you. Again, it's an honor and pleasure to be here and with you today. Uh, Thank you so much.